In this sublesson, we'll talk about IP tables, which is the Linux kernel's firewall. IP tables is a stateful packet filtering firewall. What this means is that the IP table software is aware of connection state. For instance, it can distinguish between a brand new connection and a connection that has already existed. In fact, it's aware of that for every connection across the system. It can have a performance impact if you get to too many connections, but it's really a powerful feature because I can allow certain connections or disallow other connections. It's a full-featured packet filtering firewall. It's implemented directly in the kernel through its netfilter suite of system calls and hooks. And netfilter was introduced in the Linux kernel version 2.2, given that the kernel is now at version 3.11, I believe. It's quite a mature product. So there's several concepts we need to master in order to understand IP tables firewalls: rules, chains, and tables. So rules search for specific criteria on incoming or outgoing packets, or just network packets in general, and then apply some predefined action against a target. So let's just hold that thought for a minute. A collection of rules are applied to chains, which determine when packets are examined. And then finally, there are different tables that say which targets are valid and which chains exist. This might be clarified by looking at a graphic. So let's look at this example of a host with two network interfaces, or maybe just even one, but in this example, let's say there are two. So we have inbound traffic to a given interface. This would be for the NAT table, which is one of the tables available under IP tables. We have several different chains. The pre-routing chain is what takes action when a packet is first received and before the kernel has determined what to do with that packet. We have two choices then. If the packet is not destined for the local system, then it goes on to the forward chain. So if you can recall, we configured IP forward to yes or no when we were looking at the /proc file system. If IP forward was no, the forward chain wouldn't be valid. But if it's yes, then we can forward packets along and it might hit the forward chain. Alternatively, it could go down the input path, meaning that this packet is destined for this system and it should go look at the input chain. On the bottom of the diagram here, we show the output chain and the post-routing chain. So they're just like what they sound like. Output is for packets leaving the system. So it searches that rules in that chain match against outgoing packets. So my system is initiating a connection outbound to some other system. And post-routing is after all of the routing rules have been applied, just before the packet goes on the wire onto the network, that applies some rules. So let's look at a few existing targets. Some of these are pretty self-explanatory for the most part. First of all, accept. This means accept that matched packet, allow it through the system, so the firewall is not blocking it. Drop means we'll drop the matched packet, don't allow it through the system. Reject is very much like drop, but rather than just dropping it and not saying anything, it drops the packet and it tells the system that made the request, sorry, I'm dropping this, it's not allowed. There's also a couple more rules. The log target, the kernel will log that this particular packet match, so this can be useful, for instance, to see if somebody's trying to hack your system. You could log hack attempts. And finally, redirect says to send this packet on to another host. So let's see some examples on the command line. I'm logged into my CentOS system, and I can type sudo lsmod, and I can pipe it to grep for table. Oops, I need to not have typos. So we can see the module is loaded. So it's implemented as a kernel module, and you can see that that it's currently loaded, so it should be available to us. One way on CentOS to examine the firewall, the current firewall, is sudo service IP tables status. So let's go through this. So we're looking here at the filter table. This is the table that filters inbound and outbound packets. It's a very common table to apply rules to. Let's look through the rules kind of one at a time. First of all, we see that all packets are accepted from all sources to all destinations if they're in the state related or established. So this is saying that if the connection already exists, just go ahead and allow it. We don't need to do any further analysis of it. It's already been established anyway. So we're distinguishing here between new connections, which would be like I have a web server listening and somebody wants a new request. That would be a new connection, versus related or existing connections. Here we're saying this next line, line 2, chain rule number 2, is for ICMP packets specifically. Look at the column header here, it says proto for protocol. ICMP packets specifically. So this is basically, it's allowing pings or any other ICMP traffic on all interfaces from all sources to all destinations. This line we're going to come back to in a moment. It looks like it says all protocols allow from all sources to all destination. It looks like it's wide open, but this is misleading, and it has to do with the fact that we're just missing some output here. In fact, let's just go ahead and show that now. If we show IP tables minus V minus L, so this output is showing minus L without the minus V. Minus V shows us verbose information, and we can really see, if we look at the same rule, this rule, we can see an interface. So it's showing us that it's applied to the loopback interface only. So that means it's allowing all traffic to and from, but only on the loopback interface, which is the local system. It's not very risky to do that. The next line we're looking at, this is saying accept these packets. This is the TCP protocol. No interface is specified, so it's for all interfaces. It's from anywhere to anywhere, and these are for new connections, and it's for SSH. Destination port is what this DPT stands for, SSH. So this is saying allow new connections to port SSH. It's allowing inbound SSH connections. This is why from the Ubuntu system to the CentOS system, we're allowed to establish SSH. And finally, at the end, we're rejecting everything else. We're saying reject with ICMP error message, don't allow anything else, and tell them that they're not allowed. So this is on inbound, incoming packets to our system. On forward, we're rejecting everything. This is the forward chain. Don't allow any packets to be forwarded at all, and we don't have any rules at all on our output chain. So that's kind of what a default firewall might look like. Let's see if we can change this at all. We might want to, say, add a new rule. We could cd, these rules are configured and saved in etc sysconfig IP tables. I need to use sudo to look at this. So if we look at this, we can compare this configuration file to our output in the command above, and it should all match. So we're saying here, allow or accept establish and related connections, or allow all ICMP protocol packets, which we talked about, or allow everything for the loopback interface only. Here's the rule that allows for destination port 22. Now you remember that we did a port forward example using SSH, where we allowed the Ubuntu host to connect to the CentOS host by using SSH port forward on port 8000. What if we just wanted to allow the Ubuntu host to talk directly to the CentOS host on port 80? We could add an IP tables rule for that. So what I like to do is edit this configuration file, IP tables, and we'll try to copy an example of a rule that's already in place. So this rule looks like a good one because all we need to do is change port 22 to port 80. SSH is on port 22, web traffic is on port 80. So I'll copy and paste this line, and I'm just kind of going through all of this. I want to allow new connections on port 80. And now I can say sudo service IP tables restart. This will reload the IP tables configuration. Now if I do sudo IP tables minus L, now you can see that port 80 is allowed. HTTP has been added. So new connections, at this point, a connection from Ubuntu to CentOS on port 80 would work, would be successful. Now sometimes you just want to disable the firewall. You don't want to have a local firewall running. Sudo service IP tables stop will disable it, and sudo check config IP tables off will turn it off permanently. Now this is risky. At this point, the system doesn't have any firewall in place, so any remote system could connect to any port that this host is listening on. It's really a good idea to have a firewall running if you can. That's the basics of covering IP tables on a Linux system to configure a host-based firewall.